In this video, I want to provide the solution to exercise level 2 from integral on the section on the general binomial expansion. And part 1 asks us to find the first three terms of the binomial expansion of 1 over the square root of 1 minus 2x squared. Well, we should have lots of practice at doing this now, so let's go. But let's do this quickly. This is 1 minus 2x to the power of negative a half. And then using our general binomial expansion, this is 1 plus minus a half times minus 2x plus minus a half times minus 3 over 2 all over 2 factorial times minus 2x squared plus the higher order terms. And the question only asks for the first three terms, and notice this is three terms, so we're going to stop here. Then simplifying this, we get 1 plus x plus 3 over 2 x squared. And that is the first three terms of our binomial expansion, which is valid when 2x is between negative 1 and 1, or x is between negative a half and a half. Part 2 asks us to show something that is apparently unrelated. So it asks us to show that this 1 over the square root of 0.8 is equal to root 5 over 2. So let's start by writing 0.8 as a fraction. So this is 1 over the square root of 8 over 10, or 4 over 5. And we know that this is equal to 1 over root 4, which is 2, over root 5. Well, that is just the reciprocal of 2 over root 5, which is root 5 over 2, as required. Okay, and in part 3, part 1 and 2 come together, and it tells us we're going to substitute x equals 1 into our expansion from 1. So let's do that. If we take our expansion from 1, well, actually, I'm going to write down first the conclusion of 1. So the conclusion of 1 was that 1 over the square root of 1 minus 2x is equal to 1 plus x plus 3 over 2 x squared plus the remaining terms. But if we've got a small enough x, we can say that 1 over the square root of 1 minus 2x is approximately equal to 1 plus x plus 3 over 2 x squared, because these remaining terms here, the x cubed term, the x to the power of 4 term, for really small x, they're going to get very small very quickly. So we can make this approximation if x is small. And we're asked to use x equals 0.1. And we're asked to use x equals 0.1. So notice x is small and it is in our range of validity. It is between minus a half and a half. So we substitute this into both sides. We get 1 over the square root of 1 minus 0.2 is approximately equal to 1 plus x, which is 0.1, plus 3 over 2, lots of 0.1 squared, which is 0.01. Okay, well, this left-hand side is just 1 over the square root of 0.8, which is nice because we were asked about 1 over the square root of 0.8 in part 2. And this right-hand side is equal to 1.1 plus 3 over 2 times, and that's 1 over 100. So actually, what is this? This is 1.1 plus 3 over 200, which is 1.1 plus 0.015, which is 1.115. So what can we, and notice I've done this without a calculator, so it shows that we can start calculating approximations of square roots without having to resort to our calculator. So what can we say? We can say that 1 over the square root of 0.8 is approximately equal to 1.115. But what have we shown in part 2 about 1 over the square root of 0.8? We've shown that it is equal to root 5 over 2. So we can say that root 5 over 2 is approximately equal to 1.115. And therefore, root 5 is approximately equal to 2 lots of 1.115, which is 2.23. So we've got an approximation for root 5, and we're saying that root 5 is approximately 2.23. Okay, part 4 asks us to find the percentage error in this calculation. So our calculated value for the square root of 5 is 2.23. Our actual value is just the square root of 5, and we are going to use a calculator for this. I'm going to multiply this by 100, so we get a percentage. And this comes out as 99.729% to 3 decimal places. So what error have we got there? Well, notice that says that it's slightly less than 100% of what it should be. So it's a slight underestimate. But if we do 100 subtract our 99.792, which is 0.271%, we can see we have a percentage error of 0.271% to 3 decimal places, which is not bad really. We've shown that just by taking the first 3 terms of the binomial expansion, we can approximate the square root of 5 to an error of 0.271%. And I think that's really quite good.